All right, here we are again. We're doing a little backyard bushery here, and I think some viewers might find this interesting. So I've got, again, the ugliest car potentially ever made here, an HHR 2008. The engine crankshaft was, I guess they spun some rod bearings, and so pretty much was knocking and needed a new engine. I just thought I was smart and asked ChatGTP what years would fit. Spat out a bunch of different models, different years. Got on the marketplace, got myself a cheap $100 engine from a Pontiac Pursuit 2006. Come to find out, crankshafts are not the same. And as you can see, this is a Reluctor 58 tooth, and this one only has 6 tooth. So something has to be done about the crankshaft. This one is worn out to crap, so that's just garbage. I'm thinking of trying to MacGyver something here, and that's what's going to be the point of this video. Otherwise, these two engines are non-VVT, but the heads are not the same. Now they're both upside down now, but basically one of the heads has a pickup for the cam position, and that's the newer 2008, and the other one does not. So now I gotta swap the head. The other one's actually still on the block here, but on this side it's upside down, but on the other engine there's a pickup there, and this one does not. So otherwise they look the same. So I'm going to swap over the head because the ECM in this car needs to read cam position and crankshaft position at a 58 teeth, which is like 6C minus 2, I think. Anyway, so I was thinking, how can I transfer this over here? I was thinking of machining down the crank a little bit. I think I have the capability to do that, but that would mess up the weight and unbalance. It would go out of balance because this part is thicker. So if I don't make this flat, I have to take off too much of the weight, and I don't want to get this crankshaft rebalanced. So now I came up with the bright idea of maybe just cutting a sliver out of this, just so you just have the teeth and a little bit of material here holding its shape, and then just machining just the width of this part, which is the same diameter, same width all around. So I would notch this. So I'd take a little material off here, and here I'd be notching it so that that fits into a groove. I would slice that, compress it on, weld it, perhaps GB weld it on there, or something of sorts. And otherwise, I might just go get another crankshaft from the junkyard, but you know, I'm feeling adventurous. I might try to do this, and it'll make maybe some inspiration for crazy ideas like this on other engines for all you guys that are modifying stuff and swapping cranks. And by the way, this is
Ecotec.
an Eco Diesel 2.2 liter. So a 2006 did not have the same ECM as a 2008. And after that, after the 2008, it became VVT. So there's only a few years that are identical to this. Mind you, the crankshaft from a newer one would probably still be the same, just the top end would be different. But I guess I could maybe grab a crankshaft from a newer Ecotec. Anyway, so that's the start of this video. I'm going to get going on this crank and show you the result. here we are on my old Logan lathe. It's never turned anything so heavy before. Everything, I've got this, just put a dial gauge on this and I've got it down to 1/2 thou where I'm cutting, so it should be precise enough for who it's for. And basically, as I mentioned, I'm going to cut the width of this and just remove equal width material all around. And then I'll machine the other reluctor wheel to the size of that groove. I might put a sliver of aluminum tape underneath it before I glue it down to prevent these teeth from interfering or the metal of the cast. I'm not sure, like the other crankshaft has a gap in between the reluctor wheel and the cast iron, so I'm not sure if the cast iron will, the fact that it's only the thickness of the reluctor wheel, if it'll still work. We're really in experimental phase here, so, but I'm still willing to try it. I think might be able to simulate that if I can figure out what the signal should be coming from the sensor. I might try turning it once it's inside the engine and see if I read the correct signal. I'll do some research on that too before I put it all back together. But here we go. We're gonna start cutting here. Should be interesting. All right, so we're back. I machined down a groove in the reluctor, in the existing reluctor. And the idea is I think I took approximately equal amount of material all around. So hopefully it's not going to mess up the balance. And now I have to cut this reluctor so that it fits into this groove. Kind of like that. You can see it from the top that there's just enough for a sliver of metal to hold that thing all together. And my hope that the sensor doesn't get messed up because of this piece of cast that's solid here, and that it's more focused in the middle and picks that up, because that could mess things up quite a bit. But I think the sensor is kind of focused right around the middle here. So hopefully this works. It'll be like sitting like this. And looking at the weight, if I use these notches, these existing notches, as knowing which one is 180 degrees, there's another one on the other side, I can weld a little tab on the what's left of this reluctor right here, and maybe screw in a little screw on each side so it keeps it balanced. Tab be the same size on each side, and that'll lock it in so this thing can't turn and shouldn't affect the sensor since it's on the side. So that is the plan. Yeah, this is experimental stuff, you know. We have no idea. Could work, could not work, could be a horrible fail. It would suck to have to take the engine back out and swap in another crankshaft, but I guess that will be I wouldn't have to reopen the head. I could take it off from the bottom end, and yeah, that is plan B. See what happens. All right, now we're getting somewhere. Turns out I didn't even have to cut it. By starting from this side, sinking it in the groove, there's enough edge with no ridge on the side. I had to kind of force it a little bit, but I was able to get it right on there, which is not in the right position right now, but I think I'll be able to turn it. I actually made this thing a little smaller, but I'm still gonna do the tabs on the sides. I made some lines on the other crankshaft in reference to the parting lines of the mold, and that's maybe not perfect, but hopefully I can get it close enough with that where it's running correctly and the ECM corrects the rest, hopefully. Yeah, I'm not sure, but anyways. So yeah, the way I did that is I just cut from the other side. My lathe is not big enough to actually use my cutting tool. I do have a parting tool, but rather than that, I just took and cut like a bunch of cuts this way until I came through. And basically it was right at the edge, really right at the edge of this plate is where I cut it. So I guess I got the most material as I could. Suppose I could have cut it that way as well, but it's the perfect width. It's like super nice fit, and hopefully now the ECM will pick it up. But I kind of prevented myself from putting the aluminum there. I guess I could force it back off. Probably not. Anyways, yeah, I was thinking of putting a sliver of aluminum underneath to help the interference from the cast underneath, but too late. Now I guess I'll just weld the tabs and drill a little hole, thread it, and lock it in. All right, here we are again, moving along. So I got my two little tabs. I cut them one on top of the other, so they're pretty much the same size, or very, very close. And yeah, drilled and tapped a 8/32 hole and 8/32 countersunk screw, countersunk the little plate. And there's like the weight is thicker right here, so the extra amount of material shouldn't interfere with anything because it's lower at this spot. You can see the lump right here. This is it's a little more easy to see like this, so that shouldn't affect anything. Being that the weight is identical on both sides, should be pretty close. I'm not sure how much weight would make this thing catastrophically fail, well, at high RPM, or affect the longevity of the engine, but we're gonna find out, maybe. If it's real quick, because I won't keep this car very long. It's just a fun little project here. So now I just gotta weld this, and that should keep it from moving. Hopefully keep it from wobbling a little bit, because I noticed this could kind of move left and right, so that might solidify that a little bit. And yeah, and that should be it. Then I start putting the engine back together. All right, just taped up my journals with fiberglass tape and covered everything up, and I just went and gave her a little weld, sanded it down a little bit, trying not to remove too much material because this needs to stay strong. I'm a little concerned that this thing will vibrate while it's running and break off like right there, because there's really not a lot of material there. But the fact that it's just going in circular motion, maybe it'll be okay. I don't know. Anyway, that's that could only be fixed by strengthening this, and you'd mess up the weight again. So yeah, I guess this ain't the greatest. Should have made it a little more tighter too, but hey, start reassembling now. Put some Loctite on these screws and see what happens. Okay, now I got the crankshaft back in the block. As you can see, it's real close, and for something that I kind of eyeballed, it's pretty much bang on where I want it. It's reading right at the center of where the holes are, so a little bit this way, which is good, not too close to this. Anyways, this might work. All right, so we're back here. I've driven this car runs pretty good. So the whole Reluctor mod seems to be holding up. I took it down for a drive, but as you can see, I reopened the valve cover here because I have some ticking going on. And remember, this is the old head, the one that was probably contaminated with metal shavings from the bearings falling apart. So I had some ticking, and I think the lifters, hydraulic lifters, got clogged up. And as you can see, these ones here are quite loose. So I'd like to pull these hydraulic lifters, maybe change them or clean them. I could use the donor head, maybe, and swap over some of those in there, or take these out and clean them in case they're different. Like as you can see here, I made some X's on the ones that are not compressed by the cam right now. Like this is the way they're supposed to be, like tight. And any ones that are loose, I will clean them or replace them. So a bunch of them are fine so far, just these two I found, but I'm gonna turn the engine, get these cam lobes to turn over to where they're relaxed, and recheck them. So you know, when you're using used parts and contaminated parts, I guess I could have tore into this thing and before putting it back on, but you know, sometimes you get lucky. Maybe if I would have drive it down the highway, they would have cleared up eventually, but I don't want to take a chance. So we'll clear. Right, we're back. The engine's all back together, and it sounds way better. Those two lifters that I pointed out, I robbed two out of here, of this donor head, and installed them in those positions where I pointed them out. And I had a hell of a time taking them out. Like when I pulled, the center part pulled out, and the sleeve, which I have somewhere here, this thing, as you can see, I fought with it to pull this out. And what it ended up working was an easy out. I used an easy out that fit just in here, and that just got it to turn. So once I got it to turn, one of them popped out, but the other one I had to use one of these expanding pullers. On the inside of this, there's actually like a groove, so this was able to grab that groove, and I just yanked it out. I couldn't actually fit the slap hammer in here, but I pried on this tool and pulled it out finally. But the easy out kind of got it turning in the beginning, so that's how that worked out. And the timing chain, I rotated the engine until I finally got the lines to line up on the chain. It took like 10 turns, really annoying, but I wanted it to be in that position so that I knew that all my timing marks were in line. Then I tied the chain with a bungee cord, like I mentioned, took the sprocket out, kind of held the chain and made sure it always had tension on it while I was attaching it to the bungee. I had removed the timing chain tensioner so that I have enough slack in the chain to remove the sprocket. And it all worked out. At one time, this actually skipped a tooth while I was trying to line up the sprocket. This skipped a tooth, and I was kind of afraid that maybe it would have skipped a tooth at the bottom. So when I finally started the engine, I was like, it's either it blows up or it's good. But turns out it's good. And here, we're going to pause the video for a sec and start up the car and show you how it sounds. Here we go, turning the key. Listen to that purr. That's a cold start. No ticking at all. This engine now sounds very nice compared to what it did. It kind of did like this. Every time you'd rev it up, it did like tick, 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 you know. Lifter knock. Hydraulic lifters, when they don't hydraulically lift, that's what happens. So I could end this video right now, but I'm gonna do another highway test, and I'll end it there. So see you in a second after that. Quickly, I didn't talk about me cleaning out the holes. So this is the donor head, just an example. But so when I went to put the lifter I pull out of here in the other head, it was kind of stiff going in. So I used one of these honing stones and just lightly turned it and cleaned out the hole a little bit. I had it nicely oiled, and I cleaned the lifter with a little bit of Scotch-Brite. It might have been just some, like, I don't know, piece of metal from when the crank bearings let go. Maybe some shavings from that ended up in the oil system and ended up in here and made the things jam. I'm not sure. Maybe the lifters were just tired and failed, because it's, you know, it's got 170K, but that's kilometers. It's not a lot, but, you know, anyway. I bought these on AliExpress. I have a whole wad of them, all different diameters, you know, and they're great for doing this kind of thing. It's a little rough to use this on aluminum, but in this case, I just went really lightly with it, actually by hand, and always kept turning it as I was moving it, not just yanking it out and scoring everything. So just like kind of like when you hone a cylinder, piston cylinder, you know, you can use these on brake calipers and that kind of stuff to rehone the cylinders. You know, they're real practical. These are about, some of them are 300 and 240. This is 240 grit, this particular one. Some of them are a little more fine, some of them are a little more rough, but I had to spend like $100 to get like a whole different assortment. I bought like all the sizes, different sizes I could find, but real handy tool. All right, we're back. And as you can see, we got a different project in the shop. I'd love to show you the old HHR, but it's gone. One of my good friends took it and is driving it regularly. We've highway tested it together. We've driven it. He's driven it quite a bit. And everything's running fine, quite incredibly. So this was a success. I guess if the whole thing blows up in the next year or two, I'll update the video comments and I'll write how many kilometers roughly it happened in. And but it runs really good, actually, like really good. Like the engine doesn't smoke, and the ticking noise is gone after changing up those lifters. And yeah, that's it for now. If you like this kind of crazy stuff, like, comment, you know, the drill. Hopefully someone's still watching out there. Maybe one day I'll be able to post more regularly, but for now, I only get the time that I have in between my personal work and jobs. So we'll see you guys later.